everyone, John here. I got mathematical going with a graph of a wave packet in free space. A little bit of quantum mechanics for you here. I really like this program. I've been playing with it for a couple of months, and it's very good for helping yourself understand some of the basics of quantum mechanics because you can graph the wave function. You can play with the variables and see how it changes, and some things become a little bit more intuitive. And also, it helps you with your differential equations and integrals and whatnot. But I got a small um, I got a small demo of one of the functions called the manipulator, where um, where we're showing the time evolution of a wave packet. So here, and I did a previous video showing, real fast how I typed this up, and I think it took me about 12 minutes to do this whole document. Well, a couple seconds plus because I added the title at the end, so you can you can add that to it. So this is my wave packet. This is our wave packet moving through space. I have time going from t equals 0 to t equals 10 and just going back and forth. But as you can see here with our wave function, you can see initially the packet is held together with a very defined with a very defined bell, and then as time progresses, it spreads, and so we know this wave function is spreading. In the places where I've learned, that's what we call it. And we can also see as the packet evolves, if my wave number is increased, my frequency increases, as you can see here. As my wave number decreases, the frequency decreases. And when that happens, we also know that by default the total energy decreases because our frequency is just the our total energy is just the frequency times the reduced Planck's constant. And also our packet's going to move slower. If the wave number is lower, that means our momentum is lower because our momentum is just the wave number times the reduced Planck's constant. So that's good something that you can just easily see. You can stop the graph, pull the wave function to where you want, increase other values, and see what's going on. So I'm moving the momentum, and it looks like the particle is moving, but actually, we're at a specific time, and so if it's moving faster, that means it would have traveled farther at that same time. So that's what's happening as you increase the momentum. That means at that same time, now it's going to be, let's say 10 meters out or 10 micrometers out. However, I don't have units in here. Everything right now is unitless. We can see it move. If we increase our mass, we can see how. Let's get a little bit more definition to our wave there. We can see how it slows down drastically. If you have a lot of mass, we see how it's moving very slow. If you have very little mass, you can see how it turns into Speedy Gonzales. But it also spreads very fast. The more mass you have, the more defined it stays. And so if I have a high mass, it will stay in the bell shape much longer. So that you can think of larger particles, like our atoms are with multiple protons and neutrons, larger mass. They're more stable, something like that. Versus an electron, it's easier for us to tell where the and when I say stable, I don't mean decay. I mean we know where it is. So if I know where a large particle like atom is, it has a lot of mass. I can more or less pinpoint it much easier in a small location versus an electron, which has very little mass. So my probability of that, knowing where that electron spreads out over a larger area. And so we also see we can play with the width of the packet. Now, I'm not gonna lie, I'm not a part of a physicist. I know that I can read these books and plug in these equations and get some intuitive knowledge, but I honestly don't know why we use the Gaussian um, distribution for the free particle. It doesn't really explain in the books. I've done some research on Wikipedia. I have not actually looked at any experience or experiments or talked to any particle physicists, but from everything I've read, it just seems like maybe they've done the experiments. They have seen the wave function collapse, and they've taken data of the position of a particular particle, whether it's a photon, electron, or whatever. And I guess if it's moving in free space or as free as it can be, the data forms a Gaussian distribution. That's the only explanation I have right now. At least it's not even an explanation. It's my best guess because I have no clue. Um, more research is needed. Okay, well that's this nifty little tool. Um, I love playing with these things. This is one of the more basic functions. I was able to put this together real quick and show you guys, but it would also do 3D graphs. It would do more complex calculations. You can have particles in a box. You can have your harmonic oscillator. It will do all of that, and hopefully I'll be able to put together some more products to be able to show you guys those things as well. So if you have any questions or comments, let me know. Like I said, I'm still learning this. So if you have any suggestions about the use of mathematical or in the application of quantum mechanics, if I'm doing anything wrong or any suggestions on something that I could post on, that would be helpful. Uh, um, Looking forward to great comments or discussion as well. Uh, that's always welcome. So I hope you guys find this interesting, and I'll leave a I'll leave a link to this document. Actually, if you have Mathematica, you can download the code. Um, if you don't have Mathematica, I believe you can still play with it on the internet through the Wolfram Cloud. I'll leave a link for it for you to go and check it out. So that's all, guys. That's all I got for you guys today. So take care, and see you next time.